Hey everyone, welcome back to Youlan's channel. Today we'll begin our first subunit of Unit 3, Sensation and Perception, and today we'll be focusing more on the principles of sensation. If you haven't watched my previous videos on Unit 3, in Unit 2 and Unit 1, Scientific Foundation of Psychology and Biological Basis of Behavior, please do so because some of the content are really overlapping and it's really good to have a background knowledge before we actually start diving into before we actually start a new unit. So, just a quick introduction about myself too. So I'm Youlan, I'm from Canada. I'm a high school student and I self-studied AP Psychology last year and I scored a 5 on it. So that's why I really want to share some of my experiences and the materials I've used to be preparing for this exam, and also just I don't know, give some useful practical tips in how to do the exam in general. So yeah, let's begin. So sensation is a process where our sensory receptors and brain interpret the stimulus energies around us from our environment. We're able to process information in two different ways. The first one is bottom-up processing, and it starts at the sensory receptors and works up to the brain. Most of the information associated with bottom-up processing has to do with your five senses: sight, hearing, smell, taste, and touch. For example, we can detect the lines, angles, and colors that form a flower. In contrast to bottom-up processing, we have top-down processing, which constructs perception, the organization of sensory information from the sensory input collected by drawing on experiences and expectations. Basically, it's when you interpret what your senses detect. You use your memories, history, experiences, and emotion to interpret different events. Sensation is like the feeling your socks when you put on them. But after a while, you tend to forget about those socks and not feel them again, right? That's because of a combination of sensory adaptation and sensory habituation. Sensory adaptation refers to the situation where you have decreasing responses to a stimuli due to constant stimulation. Sensory habituation refers to your perception of sensation depending on how much you focus on them. Your sensation is dependent on your senses, but it can also be dependent on perception. Your sensation can be thought as the physical senses, but we also have senses that help us know our body position, which is called body position senses, which is really simple, from its name suggests, though you will learn this in more depth in later chapters or units. The vestibular and kinesthetic sense helps your balance, weight, and positioning. Vestibular senses tells you what your body's position in relation to space, while kinesthetic senses tell you where specific body parts are positioned and oriented. All these senses are divided into three categories: energy, chemical, and body position senses. You will notice that our five common senses, vision, hearing, touch, taste, and smell, are also further divided into energy and chemical, and that's because the receptors for vision, hearing, and touch is different from taste and smell. Now we have our Gestalt Principles. How does psychology study our interpretation of sensory information? In the 1900s, a group of psychologists noticed that we tend to organize our cluster of sensations into a gestalt, or a whole form. These Gestalt psychologists have identified a number of principles that explain how we do this. In the image below, or image in the bottom right corner, you may see 8 black circles with white lines intersecting them. This is the actual visual stimuli sensation. However, you may also see a cube, although there isn't actually one there. This is your mind working to create a perception that is actually an illusion called the Necker cube, named after a Swiss scientist who first published it in 1833. It's a great example of the idea that the whole can be greater than the sum of its parts. Another aspect of perception that Gestalt psychology study is the figure-ground relationship. This principle explains how we can distinguish a subject from its background. If you look at the image, there's like a really famous image, you will see like a black background with a white lace. However, if you look at the image with the white as the background, you will see two black faces looking at each other. Our ability to view either one of these objects demonstrates the figure-ground relationship. We also tend to group different stimuli together. When we group nearby objects together, which is proximity, perceive continuous patterns rather than discontinuous ones, which is continuity, and fill in gaps to form a whole object, which is closure, which is from our example of this cube thing here on the right corner. Consider, okay, and now let's how does our brain interpret sensory information? To process sensory information, our sensory systems convert one form of energy into another form of energy. This is done through sensory transduction. With all our 5 senses, we receive the sensory information first, then transform it into neural impulses, and finally deliver the information to our brain to be further interpreted. Philosopher Gestalt Principles studied our awareness of faint stimuli and coined the term absolute threshold. This is the minimum stimulation needed to detect any stimuli 50% of the time. In basic terms, the absolute threshold is the lowest level of stimulus needed to detect a smell, a sound, or a ray of light. Stimuli that are below your absolute threshold are considered subliminal because they are there but you are not consciously aware of them. So this diagram or table on the right corner here shows this is like the absolute threshold diagram. Detecting a faint stimulus also depends on our psychological state, which has to do with the signal detection theory. This theory predicts when we detect a faint stimulus in our surroundings, being the signal among all background stimuli. Being the noise, these theories seek to understand why we respond differently to the same stimuli, and ultimately pertain it to our experiences and expectations. Along with detecting faint stimuli, how do we detect the differences between really similar stimuli? For example, how can a musician hear when their instrument is untuned? We can attribute this detection to their difference threshold, or the just noticeable difference. This is the minimum difference between 2 stimuli required for detection 50% of the time. For example, we may not feel a significant difference between a 61-pound weight and a 62-pound weight. However, we will feel a significant difference between a 50 lb weight and a 100 lb weight. Ernst Weber noted the Weber's law, which states that to perceive a difference, 2 stimuli must differ by a constant amount. When stimulus is unchanging, you eventually become less sensitive of it. This is known as sensory adaptation, which we mentioned previously, where our nerve cells fire less frequently. Another example of sensory adaptation is when you walk outside. You might first smell the fresh smell of grass, right? Eventually, though, the smell just disappears and you no longer smell grass even though you are outside. This is because you adapted to the scent and are no longer aware of it. Sensory adaptation allows us to focus on changes in our surroundings amongst background noise. So this is the end of our video today. If you really like it, please like and subscribe.